Okay, good morning, students. Now, for this case, we want to calculate the centroid. Let us say the given shape, this is the shape. This is the shape given by him. For this shaded area, I want to calculate the centroid. So, it is a shaded area. For this case, I need to calculate the centroid. So, it is not like similar to our regular triangular shape, where he was given the origin as here. Now, the origin is here. This is x-axis. This is the y-axis he was given. Okay. Now I want to calculate the centroid for this shaded area. So now I'm going to dividing this area into this area into two right angle triangles. See, first one is now give the names here. This is A, this is B, this point is O, and this point is C. So that you can understand. Now take the triangle, larger triangle AO, ABC. This is the ABC triangle A, B, C. So, but the origin is here. We know that origin is here indirectly. I'm making a choice of this one. The origin is here. I'm writing here the origin. This is x-axis. This is y-axis. This will be the x-axis. You know that. So this entire triangle ABC we need to subtract because I need the AOC region. I need to take the entire triangle that is ABC. From this area, I need to subtract. That means this is the entire area I need to take here. I am showing here for a convenient purpose. I am shading this area. This is the total triangle I am taking initially. This entire triangular shape I am taking here. Okay. It is triangle ABC I was taking here. From this area, I need to subtract triangle ABO because I want to get the centroid for the AOC triangle. So that means this is the triangle ABO. You know that here. This is the triangle ABO. There you know that this is a right angle triangle ABC. This is ABO. A, B, and just for convenient purpose, I'm showing you. This is the C point here. And the origin is here at O point. You know that. X-axis. Okay. So that means from this entire triangle ABC, I need to subtract ABO. For convenience purpose, I'm shading this one also. Then only we will get the triangle AOC, which I need to measure the centroid. So the dimensions are like this. This entire triangle length will be 3 plus 6 means 9 centimeters. Will be 9 centimeters. Whereas this dimension is 3 centimeters. Whereas this dimension is 6 centimeters. So for the first area, no, already I told you this is the first area. That is, in this case, we divide the to get the centroid. Triangle ABC is the first area. The first area we divided here. The first area, this one. From this area, we have to remove this triangular area ABO. That is the second area. This is the second area. Okay. And we know that the dimensions are like this. Same. This is the 3 centimeters. This will be the 6 centimeters. First, calculate as usual. Write the coordinates. Assume for this right angle triangle, the centroid is somewhere else. We doesn't know where it is exactly. So for the entire triangle ABC, the centroid is first area, somewhere else C1. So we know that from the formula, from the 90 degrees, we know that as a formula from 90 degrees, we know that it is one third of the direction. That means if we taken this is entirely 9 centimeters, from 90 degrees, the distance will be one third of that length. That is 9 by, that means this length will be the 9 by 3. That means the centroid C1 lies from AB line at a distance of what 9 by 3 means here 3. 9 by 3. Total length is 9. 9 by 3. Here 3 means from this edge. From this edge it will be the 3 centimeters. 3 centimeters means, so we can say that the C1 point will lies here on the y-axis because this length is 3 centimeters. Already in the bottom we are given. That means the centroid definitely will lies on the y-axis. This is indirectly the clue here. So because it lies on y-axis, what is its x-coordinate? We have to measure the x-coordinate from the y-axis. Because it lies on the y-axis, the distance is 3 centimeters means this distance is 3 centimeters means from this AB line, the C1 point actually lies here on the y-axis. So on the y-axis means the x-coordinate will be the 0. That means x1 is equal to 0 because origin is here now. This is the origin, y-axis is here. From y-axis we have to measure the C1 distance. This is the x1 distance. And what is the y1 distance means? From 90 degrees, the same C1 point will lies in this direction, one third of the respective length. What is this? In this direction, total length 6 centimeters. So 6 by 3 means 3. Sorry, 6 by 3 means 2. 6 by 3 means 2. That means the y1 coordinate is, what the x1 coordinate is 0 and y1 coordinate is 2. And what is the area of this shape? The first area, triangular ABC, is half into base into height. Half into base is 9 centimeter. Height is, altitude to height is 6 centimeters. So total A1 area, A1 is equal to, so 9 threes, 2 threes, 8, 9, 27. So we got the respective content for the calculate the centroid for the first area. Similarly, you take the second area. This is the second area. So as well, you know that this is a 90 degrees angle. Now its centroid lies somewhere else here. C2 is the centroid. Now, as per initial formula from BC AB line, so what is the length of this one means here? It will be the 3. It will be from 90 degrees as per standard formula, it will be 1/3. So 3 by will be is equal to 1. That means this distance will be is equal to 1. But what we required, x2 coordinate means we need to require origin from the origin, that is from y-axis to this C2 distance. That means the meaning of x2 means this distance I need. So we know that the total distance is 3. The total distance is 3. Totally is 3 centimeters. From the AB line it is 1 centimeter. That is 3 by 3 means 1 from 90 degrees. But I need the x2 coordinate. That means x2 will becomes here. This entirely 3 minus 1. 3 centimeters 9 as per formula that will be the 3 by 3, that is 3 minus 1. 3 minus 1 means here 2. But sorry, I'll write a little bit separate here. Ax3 is equal to, as per formula, 3 minus 3 by 3, that is 3 minus 1 will be is equal to 2 only. But the x3 is in the second quadrant because we observe the C2 point for this triangle ABO is in the second quadrant. So because it is in the second quadrant, because it is in the second quadrant, then what is the value of the x coordinate? Because it is negative x-axis. That means the sign will be here. You have to give the sign here negative. Please remember why I was given the negative sign means here. The negative sign is for second quadrant. Similarly, it's y3 coordinate. The same C2 point from the x-axis distance. So it will be from 90 degrees, that is from this axis. Default in this direction length will be the 6 centimeters, that is 6 by, that is what we call 2 centimeters. But y2 coordinate, sorry, is x2, y2, I was written wrongly. Sorry for that. You have to note down this is because second area means it is x2, its coordinate y2. And the y2 coordinate will be, as per formula, 6 by 3 means it will be 2. But the y coordinate in the second quadrant means it will be positive because this distance in the positive y direction. This distance is in the positive y direction, that is a positive value. Where the x coordinate will be the negative direction. Hence it is a negative sign we are given. So we know the value of x2, y2, and the triangular area ABO will be, now A2 area will be is equal to half into base into height. Half into base is 3 centimeters, height is 6 centimeters. 2 into 3, 3 is 9. But here the important thing is we have to remove this area. Second area we have to subtract because you can see the sign here. Because I want to get the what I need to get here, the for which case I want to calculate triangle AOC, I need to the centroid. For this region, I need the centroid. So what I did here, I was taken the total triangle ABC and I was removed the portion, the triangle ABO. Because the second area is removed, because this is the first area, this is the second area. Because we are going to remove the second area, wherever A2 is there, give the A2 sign as negative, that is minus 9. Now we are having everything, A1 x1, A2 x2, A3, A2, X2. So now the centroid formula is general formula for the given shaded region is general formula is A1 X1 plus A2 X2 divided by A1 plus A2. So it will be is equal first area 1 27. Its x1 coordinate because it lies on y-axis, it will be 0 distance. Plus second area, because the second area we should not enter the positive sign. So because we have to remember the second area, that means the sign will be the negative. That is minus 9 is the sign into it x2 coordinate. A2 area is removing, that is the reason we are given the negative sign. Next x2 coordinate is because the coordinate also having the sign, because the second area centroid will lies on the second quadrant, then whenever the point is lying in the second quadrant means the x distance will be negative, y distance will be positive. So hence x2 will be here minus 2 because we got the 2 value only, but because it is in the second quadrant, we have to give the sign negative. That means give the sign here x2 value as minus 2 divided by a1 minus a2. A1 is 27 because area is not adding here. We are removing the area, hence it is minus. Then finally we'll get this 9 plus 2 means 18. 18 divided by 27 minus 9. 9 means here once again it will be the 18 only. So finally what we got here plus 1 centimeter. That is the positive because the centroid of the shaded area will lies on the by default first quadrant only. By we got in this case like. Similarly, take the y bar. Formula is same a1 y1 a2 y2, but the a2 sign will be negative and x2 will be negative. But here the y coordinates are there; it will be positive. First a1 27, y1 coordinate is 2 minus because the second area is we have to remember. For that reason, we are giving the sign. The second area is 9. 9 means minus because we are removing that area. So minus 9 into. And what is the y2 coordinate here for this case? Because it is in the second quadrant, but y will be the positive. That will be 2. So y2 will be positive. This is a positive value. Right? So here we will get once again 27 minus. So it will be 54 around. It will be around minus 18. So then what is the value to get here? 27, 54 minus 18 is
2 centimeters, sir.
36 by 18. So 18 twos. We got 2 centimeters. That is a positive value we got. That means I can say that finally for this case, so we are taking the this triangular case. So this is the reason we got here. This is the origin here actually. For this case, for this red colored region, we calculate the centroid. For this region, we calculate the centroid. If the origin is here, the y-axis, this is the x-axis. Now the entire shaded area centroid will be lies here. This is the centroid of this shaded area. It is lies in the first quadrant. Why? Because we got the x bar as positive, y bar also positive value. So whereas this is the origin, from this origin y-axis to this distance is called as x bar. So what we got x bar value as 1. And similarly, this is what we call y distance, that is y bar. Y bar will be is equal to 2 centimeters. This is y bar because it lies in the first quadrant for the shaded region. So like this, we need to take care both coordinates signs as well as areas signs. If area is removed, then we have to give the negative sign. If area is added, then we have to give the positive sign. So like this, we need to follow the things. So now we completed the, for this case, how to calculate the this shaded area region. So like this, we will go with another typical problem. So you will solve this problem the same way. So if you observe here, the next problem. So he was given, this is the semicircular shape. So if you take it, this is the semicircular area. And this is quarter circular area. So that means for this shaded area, I want to get the centroid. In between these regions, we need to get the centroid for this case. I need to get this area, this centroid, which I mark with a pink color. This case, I need to get the centroid. So, okay. So in this case, already was given the origin where it lies. I need to get the this region. This region. So now this is the origin he was given. This is the x-axis. This is the y-axis. So for our convenient purpose, I am naming the points like this. Points will be like this. So this will be A point. This will be O point. This will be P point. And now to get this centroid for this shaded region, what I am doing is I am taking the quarter circle. So we are having this quarter circle. This is origin already given. X-axis, y-axis. So I am shading this area. Entire quarter circle I am taking here. You can see I am taking this entire area as the quarter circle as the. So I am taking this entire quarter circle OA as the first area. This is the first area. But I need this region the centroid because we doesn't know that shape. So I am taking the quarter circle. There is a quarter circle as OAB. Quarter circle OAB. For the dimensions, you know that now he was given here this radius is semicircular radius is 10 centimeter. So when it is 10 means this distance is also 10. This distance is also 10. That means totally it will becomes here 20. Because it is a quarter circle, this length is 20 centimeters means automatically this length is also 20 centimeters only. Why? Because we know that quarter circle means it is 1/4 of the circle. This is the radius. This is also a radius. That means this length is here in this case 20. This length is 20. So I am writing here. This is the radius of the quarter circle. Radius will be 20 centimeters. This distance is also 20 centimeters. So from this region, from this quarter circle, what I need to do is, so we are having the semicircular shape here indirectly. I'm making a point here. So that means I need to remove the what shape? Uh, this semicircular area. That means this is the second area I need to remove. Then only I can get this shaded area. So then we know that this point is O, this point is B. That means semicircular area I need to take OB, semicircular area. This is a semicircular area I need to remove from the quarter. So taking a different color, which area I need to remove? So I need to remove this area. This semicircular area I have to remove. So for that case, we know that the semicircular area is symmetrical about, let us assume this point is C here. This point is C. This point is C. We draw a symmetrical line. This is a symmetrical line of the, because the line of the semicircular area. So that means from the quarter circle we have to remove the semicircle so that I can get this shaded region. This shape I can get. For this shape I need to calculate the centroid. Okay, we know the details here. Now apply the, for applying formula. So we know that this distance is radius. That radius will be, this radius will be, this half length will be the 10 centimeters. This will be 10 centimeters. This distance is also, because the radius of the semicircle, it is also 10 centimeters. Now, first of all, take the quarter circular shape. Is area 1 is a quarter circle. So what is a quarter circle area means? Circular area is pi r square. Quarter circle means 1/4 of this one. That means the formula will be pi r square by 4. Where r is the radius of this quarter circle. So you can write here pi by 4. Radius of this quarter circle is 20. Quarter circle radius is different, semicircular radius is different. So this area is you have to kept here. That is the sign will be the A1 positive sign default. So you calculate, you will get some value. I am not calculating here. Now if you take an for the quarter circle, this is a 90 degrees where the origin is lying here default. So the centroid for this first quarter circle will be somewhere else here. We know that as per the quarter circle formula, from this origin, that is from y-axis, it will be is equal to 4r by 3 pi. As per standard formula, this distance is also 4r by 3 pi for quarter circle from 90 degrees. From 90 degrees. That means here the x coordinate, x1 is equal to, so this is what we call x1. This is what we call y1 coordinate. Both are lying in the first quadrant, hence they are positive only. The formula is 4r by 3 pi. And 4 into radius of this quarter circle is 20. 4 into 20 by 3 pi. The pi is 3.14. You know that. Similarly, its y1 coordinate will be is equal to 4r by 3 pi is equal to 4 into 20 by. So you will get, because it is a positive value only, because the psi 1 lies in the first quadrant, the coordinate y is also positive. Everything is positive for the quarter sector. No problem. Now the next case, we have to remove the semicircular area. So what is the area of the second area? Semicircular area. This is a semicircular area. The formula is same. Semicircle means half of the circular area, that is pi r square by 2. So here pi into radius of the semicircle. What is the radius of the semicircle? This is the radius, 10 centimeter. So 10 centimeters, that is 10 squared by. But here the sign will be, because we are going to remove in the semicircular area to get the shaded region, the A2 sign will be the minus. And don't forget to substitute the minus sign for A2 value. Similarly, next it's x2 coordinate. So before going to this coordinate, we know that because in the case of semicircle, the centroid will lies on the symmetrical axis. Because the semicircle lies, this is the symmetrical axis. That means the centroid lies here on the symmetrical line. Name it as C2. So now the C2 distance from the y-axis. This is what we call x coordinate. In this case, it will be x2. So what happens in this case? X2 will becomes this distance. You know that this distance will be the radius, that is nothing but 10. That means here x2, the centroid of the second area, that is semicircular area, x2 will be is equal to r, that is 10 centimeters. By default, it is also positive because it lies in the first quadrant. But area sign will be the minus. We have to remove the second area, semicircular area. Now y2 coordinate will be is equal to. So y2 means we know that from the semicircle, already I told you, from the base, because the base is matching with x-axis here. From the base, the centroid formula will be, it will be is equal to 4r by, this is what we call y2 coordinate. It will be is equal to, as per formula, 4r by 3 pi. So that means we can say that y2 will be is equal to 4r by, because it is also positive because it lies on the first quadrant. So 4 into radius of the semicircle. What is the radius of the semicircle here? This is the radius of the semicircle, that is a 10 centimeter. 10 divided by 3. So now we got the x1, y1, x2, y2, a1, a2, but a2 sign will be the negative. Everything will be the same. We calculate the x bar by using the formula a1 x1 plus a2 x2 by a1 plus a2, where a2 we have to substitute here with a negative sign. And similarly, y bar is equal to a1 y1 plus a2 y2 by a2 y2 by a1 plus a2. Their area 2 will be negative sign. Everything will be positive. So like this, we have to calculate the centroid of the shaded area. So we completed two problems today. That is this shaded region. This is a shaded region. Okay. Similarly, second one is this is shaded region. This is shaded region. And now the similar fashion, of course, now it is a different problem. Discuss in the next class. You can try this at home. It is a what we call it is not it is a sector plus right angle triangle. So we have to take the right angle triangle plus add the sector area. It is not quarter circle. Remember the angle was given here. Angle is how much? 60 degrees. Because the angle is 60 degrees means it is not a quarter circle, it is a sector. Okay. So use the standard formulas and try to solve this problem. So these are the maximum problems we can get for any examinations. Okay, students, wait, I am stopping the recording.